This year is a landmark in terms of wastewater treatment. We're celebrating the centenary of the publication of Arden and Locket's work on activated sludge. This presentation focuses on Davyhulme and the work that was carried out there, and also looks at how the works has changed over the century. So I'm going to go through some of the changes that have happened over the years at Davyhulme Wastewater Treatment Works, and also look at some of the external factors that have driven the changes at the works, and also how the works has impacted on the development of wastewater globally. So I'd like to put into context the works development with respect to social factors. However, let's have a look at Davyhulme itself. It's United Utilities' largest wastewater treatment works. It has a really large footprint, and as you can see, it's bounded by the Manchester Ship Canal and the M60, as well as many domestic dwellings and some retail facilities. The works itself treats 1.2 million population equivalent, and the dry weather flow at the works is 340 megalitres a day, and flow-to-full treatment is 714 megalitres a day. So you can see it is a very large treatment works. So let's have a look at Manchester in the Victorian era. It was a very different place then to the Manchester that we know today. In the middle of the 1800s, there were 100 drainage areas within the city, and there were many challenges that we saw there. So, for instance, lots of overpopulation, crowding, grimy streets in the city, and that was due to the discharge of waste onto the streets. So that brought many problems, and you can imagine issues with health and well-being of the people in the area. Water had started to be brought into the city, and then there was a need to develop a drainage network. So in 1853, the Metropolitan City of Manchester was founded. So let's look at some of the changes and the growth of Manchester over the period from 1838 onwards. So you can see there's quite a lot of development as the areas and the small districts come together. The population was rising, and with that growth in population, as I've mentioned, there are many health issues that were considered. There were a number of typhoid outbreaks, and there were Royal Commission reports that were published in 1865 and 1868. There was also a Public Health Act that was brought out in 1875, and in 1876 we saw the River Pollution Act. These were measures to try and understand the impact on health and the impact on pollution in the watercourses. As drainage areas were developed, the waste was taken from the streets and actually discharged into the watercourses. So the plan and the foresight of some of the town engineers and the people at Manchester Corporation were to look at building a treatment works. So there were many developments. One of the major developments as a precursor to the opening of Davyhulme, which happened in 1894, was the opening of the Manchester Ship Canal in 1893. This meant that there was a link now from the city of Manchester to Liverpool along the Ship Canal, and that helped in terms of trading. Treatment at the new works at Davyhulme consisted in the early days of screening, followed by solid liquid separation, where sedimentation was used with chemical precipitation. This allowed us to separate solid and liquids, and the liquid element was then treated across the land and eventually discharged to the Ship Canal. The solid element was the sludge that was taken, pressed, initially disposed of into sludge lagoons or again onto land, but latterly disposal was via ships to the Irish Sea via the Manchester Ship Canal. You can see here one of the boats that was used at that time. It's the SS Joseph Thompson in the early days. Treatment at Davyhulme Treatment Works developed further, and the land filtration was replaced by contact beds or bacteria beds or percolating filters as they're known now. The next big step forward, though, was the discovery by Arden and Lockett of the activated sludge process. They published their work in 1914, and that also coincided with the start of the First World War. However, work continued at Davyhulme, and the first plant using an activated sludge plant at Davyhulme Works was running in 1918. Over the years, the flow to the works and the load that was being treated increased due to increases in population. In Manchester, the population had risen to over 500,000, and the treatment works had to be extended. So the original activated sludge plant that we saw that was running in 1914 treated only 4.5 megalitres a day. So further extensions to the treatment works were required. This first major extension to the works started in 1926 and was completed in 1934. Davyhulme over the years has been known as a site where new technologies have been developed and tried, and this continued during this extension phase. So a treatment works was being built and put in, but actually it was an opportunity to look at the design as well. So 3 different forms of activated sludge plant were installed at the time. They were a simplex unit, Sheffield bioaeration system, and a diffused air system as well. This was so that we could look at the treatment, the design, and look to optimise the whole process. We can see here some photographs in the early days of different types of aeration plant that was being developed. And these are plants in around the northwest and other parts of the UK. So now you're going to see a very short video, which is a photo montage of the Davyhulme Treatment Works over the years. There were many changes to the Davyhulme treatment works over the years, and there were also many changes in the water industry at the time. For example, in 1948 there were 32 river boards set up in England and Wales. The next big change, though, was in 1974, where the whole water industry was restructured. At this time, Manchester and Liverpool waterworks corporations were combined into an organisation that was known as North West Water Authority. Then came privatisation in 1989 and North West Water plc was formed. The next big change to us as a company was then in 1995 when North West Water and Norweb merged to form United Utilities, the company that we're known as today. Wider in the industry, though, remember, in 1998 there were changes to sludge disposal, and this was actually banned at sea. This was quite significant, especially at Davyhulme, where sludge disposal had to be reconsidered and part of the whole sludge strategy for the company was reviewed, and there were many changes made. On this slide here, you can see some of the changes in the effluent quality consents that have happened over the years. And the main thing to note here is the drive towards nutrient removal. So you can see our big challenge at the moment is heading towards a 1 milligram per litre ammonia standard. Ammonia removal is something that we've been interested in at Davyhulme over a number of years. This is mainly because Davyhulme was identified as the single major contributor to high levels of ammonia in the Mersey estuary. It was found that there were 6.5 tonnes of ammonia being discharged per day to the estuary from the works. North West Water proposed to deal with this, and a number of studies and investigations were carried out. Back in 1989, work was carried out by John Dolan and Nigel Horan, and they did some on-site trials and looked at some investigations onto different types of treatment processes that we could use. The reason we investigated so heavily at that time was because it was found previously in the 1950s and 60s that nitrification on the works was being inhibited, primarily due to the types of trade effluent that we had on site. Now, the history of the works is such that over the years there were many heavy industries in the area. For example, munitions and jet engines were developed in the local area around the time of the wars. And this heavy industry led to different types of heavy metals and some inhibitory compounds being discharged. The Northwest has got a long history of industry. If you go back to the Industrial Revolution, it was textiles and cotton. So we can see that there have been many different types of industry and discharges over the years. I suppose later days it's more along the lines of petrochemicals and electronics that we're looking at. So getting back to Davyhulme and effluent treatment and nitrification, the outcome really of the trials was that a new process that had been developed in France was given a debut. And again, Davyhulme was at the forefront here when in 1991 a pilot plant of a biostar process was tried and tested and found to be successful, and then the full-scale plant was constructed and operational. The plant in 1998 then treated all of the effluent from activated sludge plants 1 and 2, and this created the nitrification that we needed. Another major challenge for us at the treatment works is on odour control. Again, cast your mind back to those old photographs that I showed you earlier, and you'll see the development around the site. The population grew and local residents were really close to the boundary. Now, as a company, we have a responsibility to be a good neighbour to our local residents and retail organisations. Over the years, there's been a lot of heightened public awareness with regard to odour, and there have been many local action groups, and social media has obviously played a part in this as well. So with the development of domestic and retail in the area, we've found that we've had to do a lot more in terms of odour control. In 2003, a major odour control project was online. This saw the air from underneath primary tanks and the activated sludge plant, ASP1, on site being collected and treated. There were big challenges for us with this project. As I've mentioned a number of times, the flows to the works are quite large, and it is a very large treatment works, and that in itself brings many challenges. Our primary tanks here, two of these primary tanks, the circular ones, are 55-metre diameter. So to cover these was an amazing challenge. These geodesic domes you can see here were constructed over the adjacent storm tanks and then lifted into position. As you can see from the photographs, the lift occurred at night time. This was because we needed optimum weather conditions, so really low wind, to enable us to do a safe lift. A 1,000-ton crane was used because of the weight and span that was needed for the lift. It helped as well, though, having the lift overnight, because it meant that there was less interruption to the traffic on the nearby motorway. Maybe some motorists complained of UFOs landing that night, who knows? But the success of the project was down to the successful installation of these covers. Just to give you a sense of scale for the odour control plant, it's a 3-stage wet chemical scrubber on the activated sludge plant area, and the slab where the tanks are and the different processes is comparable to the size of Big Ben. So again, a big challenge to us on the site. This plant actually treats 140,000 metres cubed per hour of air that is extracted from under the covers. The next big project that we've seen at Davyhulme Wastewater Treatment Works is the SBAP project, so that's Sludge Balanced Acid Programme. And this was a project that we generated to enable us to look at solid waste in terms of a resource rather than a waste to be disposed of. The project consists of thermal hydrolysis, and it was a plant that was commissioned in 2013, so a really recent addition to the site. It was a £100 million investment, and really is the next step in innovation for the site, considering the energy requirements for the site, and this helps us in terms of reducing our energy. Next you'll see a short video on that and some of the people that were involved in the project discussing the benefits that they've seen.
We're actually on the Davyhulme Wastewater Treatment Works site. What you can actually see is part of the thermal hydrolysis plant that's been situated here.
Current situation with the United Utilities is we produce about 210,000 tonnes dry solid a year of sludge, most of which goes to arable agricultural land. That land bank is under tremendous pressure.
40% of United Utilities sludge comes through this site. Because the plant behind us actually takes the sludge up to greater than 100 degrees Celsius at high pressure and holds it there for sort of 20 minutes, 30 minutes or so, it kills off all the nasty bugs that people are worried about when you're spreading sludge to land. So it opens up a much broader land bank to us.
You can spread it on grassland, and in the northwest of England there's a lot more grassland than there is arable land.
The main difference between the sludge that we're getting now than the sludge that we had before is it's a lot better consistency. It doesn't run off across your yard. It's a solider product, and the smell is reduced. It puts a lot more quality into your grass. If you spread the sewage where sheep and lambs are grazing, you can tell the difference in the lambs that come off that ground, because the new stuff that's coming now, there's zero bacteria in it, whereas the other stuff, it were one off neat, I think. If we didn't have the sewage being tipped, we'd probably have to cut back on stock numbers because the ground wouldn't carry the same amount of stock, or use more expensive bag fertiliser alternatives.
We've been producing energy from sewage sludge for decades. We've been doing that now. The technology behind us, a process called thermal hydrolysis, owned by a company called Canby. The plant behind us now, as it stands today, is the world's largest thermal hydrolysis plant. So the technology cycle has enabled us to do what we've done today. I'm sure over the next 20 years it'll move on further.
The biogas that's used in the engines obviously creates power. The power is actually adequate to not only run the new process that we've installed on the rest pad, but also the entire treatment works at Davyhulme.
The energy cost to import to Davyhulme before SBAP came along was approximately £1.5 million a year. And by having this, we will actually be exporting energy. So we'll actually be saving 1.5 million and exporting that energy as well.
We're taking generally what's known as a waste, which is sludge, and really maximising the energy recovery from it.
99 years ago, activated sludge process was developed on this site, and then 9,900 years later, we're switching on and operating the world's largest plant of its kind. It's something that the site team are really proud of, I'm really proud of, and all the people in UU are really proud of.
At United Utilities, we're passionate about health and safety, and I just wanted to give you an understanding of how things have changed over the years in terms of operation and maintenance at the works. If you look at this gentleman in the normal operation at the works back in the early 1900s, personal protection equipment was definitely something that was not considered at that time. Or if it was of a very different standard to that we see today. If you notice, the hand railing and the lighting for the area is not really of the standard that we would expect on our treatment works today. So I've talked a lot about the plant and how things have changed over the years in terms of different types of technology. I think it's worthwhile to consider as well that the design and the design methods that we've used over the years, and looking at the projects from the 1900s through to the current day, the way we carry those out has changed significantly. So we're looking at the changes from drawings of the past to building information modelling, and this will enable us to review the assets that we have and manage them over the whole asset life cycle. It's a means of doing 3D models, doing some visualization, and helping us in terms of our design when we're looking at clashes, and also access lifting and maintenance and safe operation. So really it is the future for us. We can look at trends, and we have a store where all the data is at our fingertips. The next big project for Davyhulme Wastewater Treatment Works, we've termed the modernisation project. This is a project to help us in achieving our 1 milligram per litre ammonia standard, which is the next big driver for our consent. We're currently evaluating tenders for the new treatment works, and we've also commenced some enabling works on the site. Part of the project and the consideration for this is so that we have no net loss on biodiversity. As a company that's interested in protecting the environment, and that is one of our fundamental practices, then looking at the treatment works and how it could impact on the environment locally is a major consideration for this project. There will obviously be some works carried out on the site that will have an impact on local wildlife and some of the plants and species nearby. So what we've done is we've looked at neighbouring land that we own and looking at an opportunity that we could create new environments there to compensate for any losses on the treatment works. This is all part of being a good neighbour, as well as looking after the residential area and minimising the impact in terms of construction traffic as well. So what could it look like? Well, this is potentially what the new works could look like. A bit of a change that's occurred over the 120 years of the site. As you can see, the population has encroached on the site and there are many retail facilities nearby. You can possibly see the snow dome nearby as well. So the challenges have certainly been there for Davyhulme. So as you can see, Davyhulme has been at the heart of the community. The developments on the site have worked with the community in terms of allowing expansion, and the expansions on the works have had to occur because of the increased population nearby. All of that, though, is really down to the foresight of those engineers in the early days of Manchester Corporation and the work that they did in developing drainage systems and developing the wastewater treatment works. But then think back to Arden and Lockett, who, without their invention, the world of wastewater treatment would not be as it is today. They've allowed, in their invention of activated sludge, they've allowed us to expand urban communities to a degree that would not have been possible without that process. The contribution to the health and welfare of people in communities and economic expansion can really be contributed to this. So to summarise, I think Davyhulme is a site that's seen many changes over the years. It has grown and shaped itself with the community, and I really feel it's set to continue. And if you look at the new project, activated sludge is definitely going to be at the heart of the community for a long time to come.